Hello, today we are going to do section 3.4, which is going to be covering scientific notation and also how the calculator writes numbers that are really big and really small, so some calculator notation and rounding. So with scientific notation, we call it scientific notation because we use it a lot in science, because in science you are dealing with things that could be really small, like cells, and so the decimal will be a really small decimal, or maybe you are counting the number of stars in the universe, which is going to be a huge number. So scientific notation helps us to write numbers that are either really small or really big. There is a pattern. It's always going to be a single digit followed by a decimal times 10 to some power. So you'll have, I'll kind of do like a little format here. You'll have some number times 10, and then you're going to have some exponent up here for your 10. This number in the front, this has to be a number between 1 and 9. So if it's smaller than 1, then you need to move your decimal again, or if it's bigger than 9, you need to move your decimal again as well. So it has to be a number between 1 and 9. So let's look at a few examples of how we do that. This first example, we have 3,456.2. So another way that you could write that, if we wanted to put it in this format, is we're going to move this decimal so that I have a number between 1 and 9. So if I move this decimal over to here, I have 34.5. That's going to be too big. If I move it to the front, I have 0.34, which is too small. So I want to move my decimal to right behind the 3. So we moved our decimal 1, 2, 3 times to the left. So we can write this as 3.4562 times 10. And then now this exponent is how we take care of the fact that we moved our decimal over. So we just made our number, it started with a big number, right? We had 3,456. We made it smaller so that it's only 3.4562. So think about it as kind of a balancing act. If I took this number and made it smaller, then my exponent has to be bigger to balance that out. So when you move your decimal to the left, you're going to do a positive number exponent for moving it over 1, 2, 3, 4, or 1, 2, 3 times. So we're going to do 10 to the third. But like on the next one, notice that our decimal here is for 0.25345. So we're starting with a small number this time instead of a big number. So to get it into my right format, we're going to move our decimal just one place so that I have a 2 here. Remember, we want this first number to be between 1 and 9, so that we have 2.5345. And then we have our times 10, and then now to come up with our exponent, again, our little trick is we took a smaller number and we made it bigger. So to balance that, if I made my number bigger, my exponent is going to have to be a smaller number. So when you move your decimal to the right direction, your exponent is going to be a negative number. So we moved this 1 time over, and we're going to make it a -1 when we move it to the right. So let's put a little note here. So when you move your decimal to the left, that's going to give you a positive exponent. And then if you move your decimal to the right, that's going to give you a negative exponent. But the way I kind of think about it again is if I take my starting number, if I started big and I made it small, then to balance it, I need to have this be a bigger number. And if I started small and made it bigger, this is going to have to be a smaller exponent. So that's kind of another trick you can think of. Hey, so on this one, again, we want to move our decimal so that we have just one digit. So this would be 1.22689 times 10. and then we moved it once to the left, so we're going to have an exponent of 1, and because we moved it to the left, it's going to be a positive number. Okay, then this next one's kind of a trick question. First, we have 10 times this number right here. So you could do this two ways. You could first times this number by 10 and then move the decimal over, or you could turn this into scientific notation, times it by 10 that way. I think it's easier to times it by 10 first. So whenever we times anything by 10, you just add a 0 to the end, right? So it's going to be that much bigger. So our decimal, instead of being in front of the 2, is now going to be behind the 2 with a 0 behind it. So then now if I want to write that in scientific notation, my decimal is starting here. So I need to move it 1, 2, 3, 4 times to get behind that first 3. So we have 3.4562 times 10 to the power of, again, we moved it 1, 2, 3, 1, 2, 3, 4 times. So 10 to the power 4. Okay. So when you are doing calculator notation, the calculator doesn't write it quite the same way, and you might have seen this before on your calculator and not really realize what it was. Instead of doing a times 10 to an exponent, they have this little e to an exponent, but it's the same idea. So this e to the 10, that would be as being like times 10 to the power of 10. So it's the same idea. They're saying that your decimal really should be 10 times in a certain direction. So we would move it 10 times back, and that would be what your number would be. So if we write this number as an example, we're going to take this, and our exponent was a 10. So when we're undoing the scientific notation, remember on the last page, we were taking a number and putting it into scientific notation. And if we moved the decimal left, it had a positive exponent. Well, we're reversing that. So it's already in that notation. So instead of moving left, I need to move back the other direction to undo it. So I'm actually going to move it right and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it just ends up right at the back. So our number would be 3, 4, 5, 6, 7, 2, 3, 9, 5, 6. And you could put 0.0 if you want, but we moved that 10 times this way. So if we took the same number but did a negative 10 exponent, what do you think is going to happen in this case? This one was a positive 10 one, and so to undo the scientific notation, we moved it back right 10. And so to undo this one, if it's a negative 10, we're going to move it 10 in the other direction. So we would move it once, and then we would have to move it 9 more zeros. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we have the 3, and then the 4, 5, 6, 7, 2, 3, 9, 5, 6. So this would have been like our original decimal, and to put it into scientific notation, we would have had to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times over to get to here, and then we could have written it in the scientific notation. And then also let's just quickly go over some rounding really fast, because I still have students making rounding mistakes quite a bit when they're doing their answers. So a lot of the problems that you're going to run into this year and next year are going to require rounding. So when they say to round to the nearest hundredth, remember our place values. This one would be the tenths place, and then the hundredths is the second one, and then the third one would be the thousandths. So I have students, I think they forget that it starts at the tenths, and they want to say this is like the one spot, and then this would be tens and this would be hundreds, but we don't have a one spot. Kind of even sounds funny to say. So this is the tenth spot, hundredths, and then thousandths spot. So if I want to round to the nearest hundredth, I look at that second spot, and then I need to figure out, do I round up or down? And so to do that, you look at the number right before it, or right after it. So this number right here, this 4, is what determines if we round down or if we round up. So any number, if it's 4 or smaller, you're going to round down. So that means we would just keep it as 12.45. But then let's say this had been, instead of a 4, had been a 9. If it's 5 through 9, you would round up, which would mean we would turn this 5 into a 6 instead. So like on this one, they want to the nearest hundredth again. So even though there's more decimals, the hundredth spot is still the second place. So I look at the number coming after it, and this 4 still would have you round down. So it would still just be 12.45. So this 9 right here, it doesn't matter. We're only looking at the number right after the 5. Sometimes we will have story problems that have to do with money. So remember, cents, stop right there. Cents go into the hundredth spot, and you can kind of think about it as there's 100 pennies, right? So it has to go to the hundredth spot. So same as rounding up here, you took a look at the number just after it. So since this is a 3, we are going to round down, and we would say that we would have $563.15. And then on this one, they want you to round to the nearest 100. Notice that it's not hundredth. It doesn't have the TH on the end. The nearest 100 means whole $100 bills. So if this is my ones place, my tens place, my hundreds place, this is the place I'm looking at now. So I look back at the 6, and the 6, because it's bigger than 5, so remember anything 5 or bigger, you're going to round up. So we would round up and say we have $600. And because they're just having you round to the nearest 100, you don't need to worry about any of the cents or the extra decimals. So just pay attention to it if it's 100 versus hundredth. And then round to the nearest integer. Remember, an integer is a whole number. So on this one, that means they don't want any decimals. So we're looking at 12. That would still be a whole number, right? But once we get past our decimal, it's no longer a whole number. So we're looking at the number past the decimal, and that will tell us if we round up or down. So since it's a 4, we round down, and we would just say this is a 12 for the nearest whole number. So a little bit of rounding for you. Hopefully that was easy, and you guys can remember how to do that. Hey, and I have a few more examples. I want to show you how you will use scientific notation, just to make sure you know how to use all the different operations. But sometimes they are going to give you problems where the scientific notation is not in the correct format and you need to fix it. So remember, when we write scientific notation, that first number needs to have just 1 digit before the decimal. Right now we have 2 digits before the decimal. So when they say they want us to fix it, we need to fix this front part by moving that decimal one more time over, so that we get 5.99 times 10. But then we're not going to keep it to a power of 4 because I moved my decimal one more time over. So if I move my one more over to the left, remember we're taking this bigger number and making it smaller. So to keep it balanced, I need to make this number bigger. So we're going to add 1 to our exponent since we moved it 1 to the left, so that we have a power of 5. And then now it's in the proper format. We have a number where that's just 1 digit in the front, and then this exponent matches how many times we need to move our decimal. Hey, sometimes you'll be asked to multiply 2 different scientific notation numbers. So when you do this, what you're going to do is you're going to multiply the front 2 parts, your number parts. So I'm going to kind of group them. I'm going to do 7.7 times 1.2 in a group. And then you're going to put your tens together, so that we have 10 to the negative 10 being times by 10 to the negative 16. So let's do this front group first. If I do 7.7 times 1.2, we end up with 9.24. So that's going to be our front number. And then we'll have our times 10, but we need to regroup our exponents. So another reason we're doing scientific notation in this section is because this is one of our exponent rules that we learned on the first day of this unit. We have the same bases here, a 10 and a 10. So whenever you multiply 2 of the same base, you add their exponents together. So if I do negative 10 plus a negative 16, that's going to equal a negative 26. So that's going to be my exponent. And then that would be my final answer. And just a heads up, sometimes when you do multiply these two numbers right here, we were lucky, it ended up just being a 9 in the front, but you might run into a situation kind of like what we had on the last problem, where you get a number that's too big. If that happens, you need to move your decimal around so that your answer only has one digit in the front. If it has more than one digit in the front, you'll get marked wrong. Okay, let's look at a division one. Just like with the multiplying, how we multiplied the first two numbers together, we're going to divide these first two numbers. So we're going to take these two numbers and divide them. So if I do the 2.024 divided by 9.2, I get 0.22 or 0.22. And then with our tens, just like how we learned in our unit, this unit, if you have the same bases, the trick is to subtract the exponents. So I'm going to do 81 minus 37 here, and that gives me an exponent of 44. So we get 0.22 times 10 to the power of 44. But if I put this in as my answer, I'm going to get marked wrong. And that's because this first number is not in the correct format. So remember how I told you at the very beginning of the lesson, this number has to be between 1 and 9. The 0 is too small. So we need to adjust our decimal by moving this one back so that I get 2.2 times 10. But then because I moved it 1 back to the right, I need to minus 1 from my exponent to keep it balanced. So 44 subtract 1 is going to be a power of 43. And now it's in the correct format. So remember, if that happens where this number is not between 1 and 9 and it only has one digit in the front, you need to adjust your decimal again. Okay, sometimes they will ask you to just write a number in scientific notation. So remember, here's kind of our format. We have to have a number in the front times a 10 raised to some exponent. And we want this number in the front to be between 1 and 9. And so if we look here, this decimal, if I move it into the front, I have 0.4, which is too small. If I move it back, it's 42, which is too big. It's already where it needs to be. We don't actually need to move it at all. So we get just 4.258. And since I didn't move my decimal at all, it's just going to be a power of 0. So kind of a trick question on that one. So if you don't move it at all, you'll just have a times 10 to the 0. But now at least it's in that correct scientific notation format that they requested, even though it's kind of silly. Okay, let's rewrite this one as a decimal. So now we're kind of going backwards. They gave it to us in scientific notation, and they just want the decimal number back. So depending on if your exponent is positive or negative, will tell you which direction to move it. So remember, we're reversing it. So if I'm timesing by 10 to the power of 10, what that's really saying to do is times this by 10 times 10 times 10 times 10, 10 times. So this number is going to get much bigger. We need to move our decimal over this way 10 times. So if I move that over, I'm going to have 1, 2, 3, and then I'm going to have to add 7 more zeros after that. So let's just do that. We have 6, 1, 9, 5. So we moved it 1, 2, 3, and then now it'd be 4, 5, 6, 7, 8, 9, 10. So if let's go add commas. We'd have a comma there, 3 over, comma there, 3 over, comma there. So that's hundreds, thousands, millions, billions. So we're at 61,950,000 on that one. So you might run into questions where they ask you to do that. And then let's just do one more. Let's rewrite this number in scientific notation. So notice we already have a number in scientific notation, but then they have it raised to a power of 4 on the outside. So again, this is using our exponent properties that we are learning in this unit. So when you have this power out here, this number in the front counts as a base, and so does the 10. So we need to bring this power into both of the numbers so that I have 7.3 to the power of 4. And then I need to do times 10 to the negative 7 to the power of 4. So remember, when we already have a power raised to another power, do you guys remember the rule from this unit? If you have a power to a power, that's when you multiply them. We have one base with two exponents. So we want to do -7 times 4, which gives us 10 to the -28. But then we also need to do this number in the front. So we need to do that 7.3 to the power of 4. And we get this lovely number right here, 2,839.82. And notice I did say just round to 2 decimals. So this number did have more than 2, but we're just going to take the 0.82 for now. But is this answer in correct format? If I type this into my answer box, am I going to get it right? No, because this number is too big. We need to fix this front number so that we just have one digit in the front. So we need to move this decimal 1, 2, 3 times so that I have 2 point. And then remember how they said to round to just 2 decimals. I don't need to write all of this. They just want 2 on there. So I would do the 2.83, except this 9 is telling me to round up. So I want to actually round up to 2.84 times 10, but then don't just keep this -28 because we adjusted our decimal, so now I need to adjust my exponent. I moved it over 1, 2, 3 to the left, which means I need to add 3. So we're taking a -28 and adding a +3. So -28 plus 3 is going to be a -25. And that would be your correct answer. So make sure you're following all the way through and getting your answer to be in the correct format, where this front number is just a number between 1 and 9, and then you have your exponent adjusted accordingly. So that is kind of like what your homework will be like. You'll have a mix of problems like that. If you guys have any questions, please don't hesitate to reach out to me. I am here to help. Just shoot me an email and we can set up some Zoom time to get caught up. Have a good day. I'll see you later.